Preparing for a security engineering at Cloudflare interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a web application firewall rule for SQL injection without creating excessive false positives? A web application firewall inspects HTTP requests and blocks malicious patterns before they reach an application. I would combine signature rules for SQL injection with normalization, anomaly detection, rate limits, and managed rule updates. At Cloudflare's edge, I would minimize latency, support rule exceptions, and log decisions for investigation. I would measure false positives, use staged deployment, and let customers customize sensitivity. The key trade-off is stronger protection versus accidentally blocking legitimate traffic. While answering, cover signature detection, normalization, parsing, anomaly scoring, managed rules, false positive measurement, staged rollout, rule exceptions, observability, and latency at Cloudflare's edge. Question 2. How would you mitigate a large-scale DDoS attack against Cloudflare's global network? I would first classify the attack by protocol, geography, volume, and target behavior. Cloudflare can use Anycast to distribute traffic across many locations, absorb volumetric floods, and apply edge filtering before requests reach origins. For HTTP attacks, I would add behavioral controls, challenges, and targeted rate limits while protecting legitimate users. I would monitor saturation, latency, packet loss, and origin health continuously. Afterward, I would preserve evidence and tune detection based on findings. Make sure to cover detection signals, Anycast routing, volumetric and application layer attacks, scrubbing capacity, rate limiting, upstream coordination, resilience, traffic baselines, and post-incident analysis. Question 3. Explain how Anycast helps Cloudflare provide security and availability, and discuss its limitations. Anycast lets multiple Cloudflare locations advertise the same IP prefixes, so routing usually sends a client to a nearby healthy point of presence. This improves latency, spreads DDoS traffic, and allows a failed location to withdraw routes. However, BGP convergence is not instantaneous, paths are policy-driven rather than strictly geographic, and some attacks can concentrate in one region. I would combine Anycast with capacity monitoring, automated mitigation, health checks, and careful routing policies. In your answer, talk about BGP announcements, nearest site routing, attack distribution, failover, route convergence, traffic asymmetry, regional outages, capacity planning, and operational trade-offs. Question 4. How would you investigate a suspected account takeover campaign targeting customers? I would define the affected accounts and establish a timeline using authentication logs, IP reputation, device fingerprints, user agents, and login velocity. I would look for password reuse, impossible travel, failed login bursts, and successful logins followed by suspicious actions. Containment could include adaptive challenges, temporary rate limits, forced resets, token revocation, and MFA enforcement. I would preserve evidence, notify affected customers appropriately, and improve detections without relying on any single noisy signal. Be sure to mention signal correlation, credential stuffing indicators, login velocity, IP and device reputation, MFA, session revocation, customer impact, privacy controls, and incident response documentation. Question 5. What are the most important security considerations when building a Cloudflare worker? I would treat a worker as internet-facing code with strict input validation, explicit authentication, and least privilege access to bindings. Secrets should live in managed secret storage rather than source code, and outbound requests should use allolists where practical. I would review dependencies, prevent SSRF, enforce resource and rate limits, and avoid logging sensitive data. Automated tests, staged releases, rollback capability, and abuse monitoring are essential because edge code executes close to every request. Focus on input validation, least privilege, secret management, isolation, dependency risk, outbound requests, authentication, abuse controls, logging, resource limits, and safe deployment practices. Question 6. How would you secure an API exposed through Cloudflare? I would begin with an accurate API inventory and classify endpoints by sensitivity and business impact. Authentication might use short-lived OAuth tokens or MTLS, while authorization must enforce resource ownership and scopes server-side. I would validate schemas, reject unexpected methods, apply per-client rate limits, and detect replay or abnormal usage. Cloudflare controls can add WAF inspection and bot mitigation, but the origin must remain authoritative. Metrics should expose errors, abuse, latency, and unusual access patterns. Cover strong authentication, authorization, schema validation, MTLS or tokens, rate limiting, replay protection, WAF rules, inventory, abuse detection, sensitive data handling, and monitoring. Question 7. Describe a zero-trust architecture for protecting employees and internal applications. Zero trust removes implicit trust based on network location. I would authenticate every user and device, evaluate identity, device posture, application, location, and risk, then grant only the minimum required access. Internal applications should remain private rather than broadly exposed, with policy enforcement at an access proxy or gateway. Sessions need continuous evaluation and revocation. I would centralize audit logs, test policies gradually, and measure both security outcomes and employee friction. While answering, explain identity-centric access, continuous verification, device posture, least privilege, segmentation, private applications, policy enforcement points, logging, and usability considerations. Question 8. How would you detect and mitigate sophisticated bot activity while preserving legitimate automation? I would distinguish bots by intent rather than block all automation. Signals could include request sequences, timing variance, cookie behavior, browser characteristics, IP reputation, authentication context, and purchase or scraping patterns. I would combine passive scoring with selective challenges and endpoint-specific rate limits. Verified search crawlers and customer integrations should have explicit treatment. Because attackers adapt, I would monitor precision, recall, and drift, continuously retraining or revising rules from reviewed outcomes. Discuss behavioral signals, JavaScript challenges, device characteristics, rate and sequence analysis, allolists, machine learning drift, false positives, bot categories, and feedback loops. Question 9. What is your approach to TLS certificate management at global scale? At global scale, certificate management must be automated and observable. I would use ACME or an equivalent controlled issuance workflow, store private keys in hardened systems or HSM-backed services, and renew well before expiration. Deployment should support atomic rollout, regional validation, rollback, and alerting for failed renewals. I would monitor certificate transparency logs, restrict issuance permissions, rotate keys according to risk, and plan around revocation limitations rather than assuming revocation is immediate. Make sure to cover certificate issuance, ACME, private keys, HSMs, renewal automation, certificate transparency, key rotation, deployment safety, revocation limits, and expiration monitoring. Question 10. How would you design secure DNS infrastructure for a high-availability public service? I would separate authoritative DNS from recursive resolution and distribute authoritative service across diverse Anycast locations and providers where appropriate. DNSSEC would provide authenticity, with carefully protected signing keys and monitored rollover procedures. Zone changes need authenticated access, review, versioning, and rapid rollback. I would restrict transfers, harden registrar accounts with MFA, and monitor unusual record changes, query patterns, latency, and SERVFAIL rates. Resilience depends on avoiding a single provider, network, or operational dependency. In your answer, cover authoritative versus recursive DNS, DNSSEC, Anycast, zone transfers, cache behavior, poisoning, registrar security, change control, monitoring, and DDoS resilience. Question 11. How would you prevent SSRF in a proxy or edge service? I would parse and canonicalize URLs with a trusted library, allow only required schemes, and reject loopback, link local, private, metadata, and reserved address ranges across IPv4 and IPv6. Validation must occur after DNS resolution and again after redirects to address rebinding. Egress policies should restrict destinations and ports, while the service runs with minimal permissions. I would test alternate encodings, embedded credentials, redirects, and parser discrepancies, because superficial string checks are unreliable. Be sure to mention URL parsing, canonicalization, private address ranges, DNS rebinding, redirects, IPv4 and IPv6 handling, protocol restrictions, egress controls, and defense in depth. Question 12. How do you threat model a new Cloudflare security product or feature? I start by mapping assets, users, data flows, trust boundaries, and privileged operations. Then I identify realistic attackers, including malicious customers, compromised accounts, external actors, and insiders, and enumerate abuse cases using Stride or a similar framework. For each risk, I assign severity, propose preventive and detective controls, and document residual risk. I validate assumptions with design reviews, targeted testing, and telemetry. The model should evolve as architecture and attacker behavior change. Focus on assets, trust boundaries, actors, abuse cases, data flows, Stride or equivalent methods, mitigations, residual risk, testing, and threat model maintenance. Question 13. What security risks arise from caching, and how would you prevent cache poisoning or data leakage? Caching can leak personalized responses or serve attacker-controlled content to other users. I would design cache keys from every input that changes a response, validate hosts and headers, and avoid caching authenticated or sensitive content unless explicitly safe. I would honor appropriate cache control directives, prevent response splitting and poisoning, and provide authenticated purge controls. Testing should include header variations, query normalization, redirects, error responses, and concurrent requests. Performance gains are valuable only when content isolation remains correct. Discuss cache keys, unkeyed headers, host validation, authenticated content, cache control directives, poisoning vectors, purge mechanisms, isolation, and correctness testing. Question 14. How would you secure logs and telemetry used for security detection? Security logs must be useful without becoming another privacy or attack surface. I would define required fields, minimize sensitive data, tokenize identifiers where possible, synchronize timestamps, and enforce strict role-based access. Logs should be transmitted securely, protected from tampering, retained according to purpose, and monitored for pipeline failure. I would separate high-volume operational telemetry from durable forensic records, validate detection quality, and document how analysts can investigate without exposing unnecessary customer information. Cover data minimization, integrity, access control, retention, PE handling, clock synchronization, tamper resistance, sampling, alert quality, and separation between operational and forensic data. Question 15. Describe how you would respond to a vulnerability discovered in a widely deployed edge component. I would first confirm the issue, determine affected versions, exposure, exploitability, and evidence of abuse. A response team would contain risk through configuration changes, feature disablement, or traffic controls while engineers prepare and test a patch. I would coordinate disclosure and customer communication based on impact, preserve relevant evidence, and deploy progressively with strong health checks and rollback. After remediation, I would validate coverage, review detection gaps, and convert lessons into durable engineering controls. Mention triage, exploitability, containment, coordinated disclosure, emergency configuration changes, patch rollout, validation, customer communication, evidence preservation, and lessons learned. Question 16. How would you design rate limiting for a multi-tenant API platform? I would choose limits based on tenant, credential, endpoint, and sometimes source characteristics rather than only IP address. A token bucket supports controlled bursts while enforcing a long-term rate. Distributed counters require careful consistency and bounded memory, especially across edge locations. I would define fail open or fail closed behavior per endpoint, return informative headers, and separate protection limits from business quotas. Fairness, customer customization, latency, and observability determine the final design. In your answer, cover tenant identity, dimensions, token bucket or leaky bucket algorithms, distributed state, fairness, burst tolerance, fail open decisions, headers, and abuse monitoring. Question 17. How would you assess the security of a service using OAuth and JWTs? I would validate the token issuer, audience, signature, algorithm, expiration, not before time, and required scopes using a trusted key set. The service must authorize the requested resource rather than treating a valid token as universal permission. I would keep access tokens short-lived, protect refresh tokens, and consider sender-constrained tokens for high-risk operations. Key rotation needs overlap and monitoring. JWTs are credentials, not inherently secure containers, so sensitive claims require careful handling. Be sure to discuss issuer validation, audience, signature algorithms, key rotation, expiry, scopes, token storage, replay, refresh tokens, revocation, and authorization enforcement. Question 18. What would you include in a secure software supply chain strategy? I would inventory dependencies and build tools, pin versions, generate SBOMs, and verify provenance for external packages and base images. C should run with minimal permissions, isolated credentials, protected branches, and secret scanning. Build artifacts should be signed and verified before deployment, ideally from reproducible or strongly attestable processes. I would prioritize vulnerabilities by exploitability and exposure rather than raw counts, maintain rapid update paths, and rehearse response to a compromised dependency. Cover dependency pinning, provenance, SBOMs, signed artifacts, reproducible builds, isolated C, secret protection, vulnerability prioritization, review, and emergency response. Question 19. How would you balance security, performance, and reliability when deploying an edge protection rule? I would define the threat being addressed, acceptable false positive rate, latency budget, and reliability objective before implementation. New rules should begin in logging or shadow mode, then move through representative canaries and regional rollout. I would compare blocked traffic, confirmed attacks, conversion impact, origin load, latency, and error rates against baseline. Automated rollback protects availability, while customer-specific exceptions handle legitimate differences. Strong security is not successful if it causes widespread outages. Discuss risk-based enforcement, latency budgets, shadow mode, canaries, rollback, false positives, regional testing, customer impact, SLOs, and measurable success criteria. Question 20. Tell me about a security engineering project you would be proud to discuss in a Cloudflare interview. I would describe a project where I reduced account abuse incidents by combining risk-based authentication, behavioral signals, and automated response. I would explain the original threat, my ownership, architecture, rollout plan, and metrics such as takeover reduction, false positive rate, latency, and analyst effort. I would also discuss a failure, perhaps an overly aggressive rule, and how staged deployment and feedback corrected it. Cloudflare values practical security, so I would connect technical results to customer trust and reliability. Focus on clear ownership, threat and business context, measurable impact, design choices, collaboration, failure handling, customer or user outcomes, and lessons learned. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.